All right, so we're diving into chapter 10 now. So chapter 10 is all about different techniques of finding derivatives. So if you were in a regular STEM calculus class, you would be learning the derivatives of sine, cosine, tangent, and so on. You'd also learn how these derivatives came about. You would have to walk through the process. In business calculus, you don't have to do that. All I'm going to do is I'm going to give you some tools to use. You have to figure out when to use them, and that's it. You don't have to know how we got to them, but I'm going to show you just a little bit so that you can see that yes, it does work, and then we'll go from there. I'm just going to give you the tools. So in 10.2, I believe, yeah, 10.2, we're talking about just derivatives of exponential and log functions. So just kind of a quick review. Exponential functions and log functions are inverses of each other. One will undo the other. So if you have the function, let's say you have the function e raised to the 0.7t, and you wanted to get rid of the e, you would just, and let's say we have, a value over here. Let's say 6 equals that. And we wanted to get rid of the e because I want to find out what t is. You would take the ln, remember natural log, because e is the natural number, ln of both sides, and that cancels it. So now you have a straight equation. That 0.7t drops down, and now you can solve your equation for the variable t. Okay? So they undo each other. They unlock each other. Just like adding and subtracting unlock each other, multiplying and dividing unlock each other. Square root and something squared unlocks each other. The ln will unlock the e, and logs will unlock any other exponential function. Okay? So that's the basis of it. So what we're going to do is I'm going to give you, let me give you the derivatives first, and then I'll show you just one of them, how it came about. So if I'm looking for, so remember this is the verb, and it says find the derivative of e to the x. The derivative of e to the x is e to the x. So this is the one I'm going to show you. So if you remember, let me get a different color here. If you remember, derivative is all about the slope, and e to the x is an exponential function. It looks something like this. Okay? And what this says is the derivative, or the slope, is the same thing. Well, look, if I were to find the slope anywhere along this line, you can see my red is showing it has the exact same shape as the actual function. Okay? So e to the x, the derivative of e to the x is just e to the x. It's the easiest one you'll use. The derivative of any other exponential function. Okay, so this is a very generalized format. This is b, stands for your base. X is the exponent. So this is different from a function like x squared. The base is the variable, and the exponent is the number. Here, the base is the number, and the exponent is the variable. So it's very different than what we've been working with. So this is the derivative of any exponential function. And I'll give you an example so that you can actually see it. So the derivative of any exponential function is that particular exponential function times the natural log of whatever your base is. So this is the beauty of these given functions. If I color code this, you can see that all you have to do is place the base in the right position. That's it. That's all you have to do with these particular functions. You don't have to know why. You don't have to walk through the process of getting it like we did before. You don't have to use the definition of a derivative to be able to get this. You just have to know what the function is. or what the derivative is. So if I gave you an example of this, if I asked you to find the derivative of 2 raised to the x power, and I'm going to do this so that it's still color-coded. Okay, so 2 is my base, x is my exponent, so it's going to look like this. 2 is my base, so my formula for the derivative is I put my 2 in, raised to the x power, so I just repeat it, times the natural log of whatever your base is. And that's literally it. You just plug in the values where they belong. Okay, so this is derivative of e to the x is e to the x every single time. Derivative of any base raised to the x power, so any exponential function, is the base raised to the x power times ln of the base. And then another one, let me give you another. So now we're going to switch to our log. So these are considered our exponential functions. Okay, now we're going to switch to the derivative. I want you to find the derivative of the natural log of x. Okay, so the derivative of the natural log of x is always going to be 1 over x. 1 over whatever your x value is. So if I had find the derivative of ln of 3, your derivative would be 1 over 3. And that's it. That's all it is. Okay? All right, so then the last one is a little bit more complicated, but you are going to have your notes, so you aren't going to have to memorize these. So this is any log. So these are both logs. This is the natural log. This is a log of any other base. So again, I'm going to color code this. Okay, so base, remember when you write log, it's the log base b of x. That's how you would read that. So this equals 1 over x. So 1 over whatever's sitting there times 1 over ln of whatever your base is. Okay? So as an example, if I asked you to find the derivative of log base 5 of x plus 1, oops, let me do it in the right color here, like that. Your answer, the derivative, is 1 over x plus 1 times 1 over ln whatever your base is. And that's literally it. All you're doing is you're just plugging in the formula for the derivative for each one of these. Okay?